Well, I read the question. A rocket carries 1.8 into 10 to the power 4 kilogram of liquid oxygen in a vertical tank of cross-section 3 meters squared. At the liftoff, the rocket accelerates vertically upward at 2.0 meter per second squared relative to Earth. The pressure on the bottom of the tank at the liftoff is. So the values are given and we want to find the correct answer. At this point you can pause the video and try this question once or a couple of times, and then you can play back. Okay, so first let me draw my rocket. Okay, so here's my rocket, and I'm gonna give it a name, Zebra 2000, something like that, whatever. So here let's draw the tank. It's a vertical tank and the fuel is filled up to some level, right, which is a liquid oxygen, right? So this is liquid oxygen, have a mass of 1.8 into 10 to the power 4 kilogram, and the rocket is accelerating vertically upward. Let's take that is A equals 2.0 meter per second squared, right? Okay, so what we want to find is the pressure on the bottom of the tank. Okay, so here what I'm going first, I'm going to consider this liquid, I mean the fuel, which is liquid oxygen. So I can consider the fuel, and I can apply F equals ma vertically upward. Before that, I'm going to mark the forces acting on the fuel. So what are the forces acting? The weight of the fuel is vertically downward, which is, let's say, mg, and the normal reaction force acting on the liquid from the bottom of the tank, let's take that is capital R. Okay, so now I consider the fuel to fuel, which is liquid oxygen, vertically upward. I'm using Newton's second law, F equals ma. The net force equals mass times acceleration. So what are the forces acting in vertical direction? So R is vertically upward, so R, and weight of the fuel is downward, which is in the opposite direction, therefore it is minus mg equals mass times acceleration. So we get R equals mg plus ma, and R equals mg plus a, right? So now let's put the values. So here we get R equals, mass is 1.8 into 10 to the power 4 in the units of kilogram, and G is, we know, gravitational acceleration, which is 10 ms minus 2, I mean 10 meter per second squared, plus the acceleration is 2 meter per second squared, right? So we know gravitation acceleration, which is pulling the objects downward with acceleration g, we take that is roughly 10 ms minus 2, right? So this is 10. Okay, so now from Newton's third law, every action has a equal and opposite reaction. So more rigorously, every action, every force has a equal in magnitude, opposite and direction reaction. So there will be reaction force acting on the bottom of the tank from the fuel, right? And we know, so let's take that is also R because equal in magnitude, right? Okay, so we know the pressure exerted, or the pressure is, we can simply get P equals force over area, right? So here the force acting on the bottom of the tank is the normal reaction force acting on the tank from the fuel. So R over A. So we have R equals 1.8 into 10 to the power 4 into 12 divided by cross-sectional area, which is given 3 meters squared. So 3 and 12 we get 4 into 1.8 is 1 into 4, 4.8 into 4 is 3.2, so 7.2 into 10 to the power 4 in the units of Newton per meter squared. Okay, so because we get this force R in newtons and the cross section area meter squared, so we get pressure in Newton per meter squared, right? So the answer is 7.2 into 10 to the power 4, which is this one. Okay.